Good day, everyone. Our research title is Innovation of Laser Cutting Machine for Paper Products and Focus of the XYZ Mobility of Laser. The researchers are our paper's background and rationale consists the laser cutting movement, the CO2 laser cutter, the application of the laser, and the materials to cut. Our paper's background and rationale consists the laser cutting movement, the CO2 laser cutter, the application of the laser, and the materials to cut. Laser cutting is a technology that is commonly used in industrial manufacturing. It enables us to cut complex shapes without tools and at a speed similar to or faster than other cutting methods. The machine has 3-axis dimension. The X and Y axis is for the horizontal and vertical movement of the laser head, while the Z axis is supposed to match the height of the workpiece surface to the focal length of the laser to ensure that the material will not be damaged. The CO2 is an efficient laser to the highest average power for material processing for the cutting and engraving, and the application involves melting, burning, or vaporizing materials through a laser beam. The laser cutting machine focuses to cut paper only. Statement of the problem. This study aimed at developing 3-axis laser cutting machine using Arduino-based controller to address the gaps of the existing 2-axis and 3-axis laser cutting machine. Specifically, it intended to answer the following questions. First, what design should be considered upon the innovation of 3-axis movement of the laser cutting machine? Second, what development strategy should be implemented to assure that the movement of the laser cutting machine is accurate? Third, what evaluation parameters must be considered to assess the movement of the laser cutting machine's efficiency and functionality? Objectives of the study. The main objective is to develop and innovate the movement that can execute the 3-axis Arduino-based laser cutting machine. The specific objectives are, first, to design an innovative 3-axis movement of the laser cutting machine using Arduino-based microcontroller. Second, to develop and implement the accuracy of the 3-axis laser cutting machine movement using Arduino-based controller, which is programmable by the use of software. Third, to evaluate the parameters efficiency of the movement of the 3-axis laser cutting machine in order to determine the machine's functionality. In the researcher's scope and limitations, the study focuses on how to accomplish a paper laser cutting machine's movement that enables the robot wheel to move in a 3-dimensional way. The robot will work in thin materials such as paper and fine fabric. It does not seek to include the application of cutting hard materials such as thick metals, steel metals, brass, aluminum, copper, and thick plywood.
Conceptual framework. Conceptual framework is the way ideas are organized to achieve a research project's purpose and explanation. Is the most common method employed. In our research, we use the IPO method. Input are baseline research, guideline process, skills, and knowledge. And the process are designing the system, implementation, and testing. The outputs we assume is complete prototype, evaluation, and recommendation.
This is our definition of terms.
For our review of related literature, we have design and fabrication of low-cost portable laser cutting machine, LaserBot technology, low-cost laser engraved CNC machine prototype with platform Arduino, design and fabrication of 3-axis computer numerical control CNC laser cutter, and paper and fabric cutting solution using automated cutting system. Design and fabrication of 3-axis computer numerical control CNC laser cutter and paper and fabric cutting solution using automated cutting system. Design and fabrication.
Design framework. A design framework is a simple visual structure that help organize the information and ideas of a problem so you can work on it more effectively. A framework is often to compose a relevant list of categories. These categories are developed from initial research that should be a part of every new project. So these are the components of our prototype. And in a figure 3.8 shows the right side stepper motor that drives the x-axis from for the prototype's body. And in figure 3.7 shows the right side view of the prototype, which is the y-axis. And the other components are Arduino Nano, aluminum stick, V-slot, robot wheels, stepper motor, laser cutter module, timing belt, palm bearing, mini CPU fan, AC power supply, adapter USB data cable.
The development. The study discussed the development of the laser cutting robot that can cut and imprint mass materials that are often used for planning and trading. The laser diode is set and controlled on the three-dimensional pivot direction X, Y, and Z axis, which are powered by stepper engines. The Beambox V3.7.99 computer program is used for the frameworks program, and the defined plan that is intended to cut was converted into information so that the Arduino Nano microcontroller may study the information that is being communicated from the Beambox computer program. The Beambox V3.7.99 computer program is used for the frameworks program, and the defined plan that is intended to cut was converted into information so that the Arduino Nano microcontroller may study the information that is being communicated from the implementation. The study implementation is accomplished by combining all of the previous mentioned developments and enhancements, as well as considering the recommendation from earlier research. The laser cutting robot was tested after it was assembled and set up. The functioning, construction, durability, and dependability of the motor, as well as the product quality, are all tested. Unexpected outputs are unwelcome, yet solution to those errors and distribute in order to attain the desired result.
The laser cutting robot's evaluation is rated using descriptive statistics in a scale that measures the utilization of laser cutting robot in accordance with the following criteria, which are the functionality assessment, whereas the laser's interfacing connectivity, programming, and troubleshooting, the automation complexity in terms of programming concept of the stepper and servo motor, the aesthetics that assess the physical profile outlook, and the mobility of the overall output.